Okay. Now, let me share the screen again. Now, what this is trying to tell us is that V is equals to K over P, and that gives us that K is equals to what? PV. Now, this tells us that once you see inversely, this means that once volume increases, if volume increases, what happens to pressure?
Pressure decreases.
Pressure decreases, yes. When volume increases, just the way your pure water, the sachet is big. Once the volume is big, the pressure will increase. But once you start squeezing it, squashing it, as you increase the pressure of the water, the pure water, what happens to the volume? The volume of the water does what? Decreases, right? So that's exactly, that illustrates Boyle's law. That illustrates Boyle's law. So that means from here, once this thing now means that once we have for more than one pressure and more than one volume, we have P1, V1 is equals to P2,
V2, V2.
V2. So this becomes the law for Boyle's law. So remember, once volume increases, pressure decreases. That's the essence of this. That's the essence of this. What do you call it? Inverse proportionality. So that is pressure. That is Boyle's law. Barry, see, Kadlo Barry, you're welcome. All right. So from here now, this brings us to the fact that we can. Now, I'll quickly go to Charles's law so that since we have done this, but sorry, Kadlo Barry, what topic are you in chemistry?
It should be in.
Have you done gas laws?
Eh?
Have you done gas laws?
Yes.
Are you in acid, base, and salt?
Yes. I think. Yes.
Okay, so that means let's quickly go to Charles's law. This is Boyle's law we just did. Now let's go to Charles's law. Now, Charles' law, who can state Charles' law?
V1 over V2 equals
No, you're just calling the formula. State it for me. Okay. Now, Charles' law states this. Please, these are things you should know at your fingertips. There are things you should know.
Pressure.
Now, look at Boyle's law. Temperature is constant. Is your K is constant? Sorry. Temperature is constant. Now, but for pressure, for Charles's law, it states that the pressure of a given mass of a gas, nobody's writing, even though you know it, you should still see how to, you can even interpret it from your formula, that the pressure of a given mass of a gas or the volume of a given mass of a gas is directly proportional to the pressure, to the temperature. The volume of a given mass of a gas, the volume of a given mass of a gas, which is V, is directly proportional to what? Is temperature, provided that your pressure is constant. So for Charles's law, temperature is pressure is constant. So volume is directly proportional to temperature. Now this becomes that V is equals to, introducing your constant of proportionality, what will it be? V is equals to what? V is equals to what? Kadilo Barry? Look at what we did here now. Introducing your constant equal to, what did we do? What did we do? Look at this inverse. When we introduce equal to, what did we bring? K, isn't it? So now we want to introduce equal to here. What do you think we'll bring here? You will bring a constant. So what do you think it will give me now? V is equals to what? Really? Look at what we did.
C,
V
T over P.
no, yeah, that's not it. I don't want you to look at that book. That book is confusing you. In fact, do away with any chemistry book now. Let's have a new understanding of this concept, because if you keep looking at that book, if you don't understand these basics, when you're asked state Charles law, state Boyles law, that's where you get confused. You just cram them. There's no need for cramming them. All you just need to do is understand. Look at V is inversely proportional to 1 over P. And I told you that the inverse sign becomes a equal to, we introduce equal to. And whenever we introduce equal to, you must introduce a constant. So why did we introduce the constant on top? We introduced the constant on top because there was 1 over P, right? Do you understand that part? Do you understand,
Yes.
Barry C?
Yes.
Okay, now look at another one now. There is no 1 on top here. So there's no need for doing that. This becomes equal to, so what do you think V will be now equals to what? V will be equals to what? Whenever you are changing from proportionality to equal to, there must be a constant. So what do we put here now? V is equals to what? Come on, just look at this. It's the same thing. The difference is this one has 1. This one does not have 1.
1. V is equals to P times T.
Is equals to what?
Mm. Mm.
Cardillo Barry, come on, you can do this. This is not hard. I told you there must be a constant. So what do you do here now?
V equals to
Where are you looking at, Cardillo Barry? Just look at this. Look at this. B is equals to K over P. Why? Because this involves 1. There was 1 on top, so there's division. But is there division here?
No.
So what would be here now? What would
No.
be here now?
V equals to 1 over T.
There's no 1 here now. There was 1 here. So you don't need to put 1 again. So what will be here? V is equals to what?
T.
P is equals to
Okay.
KT. Simple. Was that what was difficult?
Oh, K.
I told you whenever you bring equal to, note this, it's a law. When you do proportionality in mathematics, this is just mathematics. When you did direct variation, inverse variation, joint variation, and partial variation, this is just it. B is equals to K and then T. Do you understand this?
Yes, Lord.
So what is K now? Cardillo Barry. K is what?
Is the constant 1.
Eh?
1.
How will it be 1? Make K the subject of the formula. So what is K?
Oh. K equals to V times T.
V times T.
So V over
Eh?
T.
V over T. Are you sure about that? I need you to be sure. Come on, you're looking for K. What do you do? Cardillo Barry, be sure. You're not still sure. Be sure of this. Look, you're looking for K. Then you remove anything close to K. How do you remove anything close to K? How do you do that? Cardillo Barry, you're not even sure of yourself. What about you, Idani? K is equals to what? Make K the subject of the formula from here. From here. So what is K?
V over T.
Simple. V over T. You're not sure of yourself, Kadloberry. You got it. I needed you to be sure. Remember the way I treated you guys in Deeper Life High School? You tell me the answer, I will tell you no. You be sure of yourself. I need you to be very sure. If you want to remove K, you're looking for K, divide anything that is close to K. You divide by T, T cancel T, divide by T, yeah, this becomes V over T. Now from here, for more than one volume, maybe more than one gases, it becomes V1 over T1 is equals to V2 over T2. Do you understand that?
Yes, sir.
Okay, now write. You can write now. Dan, have you written?
Right.
Okay. Okay, are you done writing?
Yes.
Okay. Now let's continue. Now the next thing is let's solve questions. Let's solve questions on these. Please write your questions down. Number one, it's 375 cm cube of a gas. 375 cm cube of a gas has a pressure of 770 millimeter mercury. Oh, I did not give you this, please. I think I should do that first. Let me give you stuff. Now, note this, please. Very, very instructive. Note this. Let me clear this. Now, note this. P is a pressure. Is measured in millimeter mercury
Make
or what? ATM. What is ATM? What is ATM? It means atmosphere. ATM. ATM, atmosphere, is also measured in Pascal. You see something like this, Pascal. You see that's PA. Most times PA. Why this one is millimeter mercury? Volume. Please write that down. Volume is measured in liters, cm cube, or sometimes you see it's dm cube. So please write these things down. T is measured in you have it as Celsius, or you have it as K. You have it as K. What else again? PVT. Okay. I think while we look at other laws, we'll look at what they are measured in. Do you understand? So please, this is very, very instructive. All right. Now let's continue. Okay, I said then that 375 cm cube of a gas has a pressure of 770 millimeter mercury. Find its volume. Find its volume. Are you writing? Are you writing?
Yes, sir.
Yeah, find its volume if the pressure is reduced to 750. Find its volume if the pressure is reduced.
Sir, please can I start again?
You said? What did you say, please?
Sir, please can I start again?
Okay, I think let's see how we can conserve time so that I think let me just send it to you. Okay, that's the first one. Are you seeing it there? Is in your chat box. Okay. Okay. So as you are seeing that, keep solving immediately. You should know the formula to use there. If you have written, that's the second one. Okay. I'm waiting. Kadluba, I hope you have your calculator there.
Yes, sir.
Okay. The same thing with Idani. Are you done? Okay, is anybody done? Are you having issues? Is Abik sub number one? Barry, Kadlo Barry, Abik sub number one?
No.
What about you, Idani? Danny, Abik sub number one?
I'm almost done. Almost done. Almost done.
Okay. Okay. If you sub number one, just tell me the answer immediately so that we don't delay. Kadlo Barry, how far? Please, if you're having issues, just tell me. Don't just keep it to yourself like that. Because of our time. Did you hear?
So it's usually number one. So
You said?
it's usually number one.
Number one, what's the answer?
1,500.
V2 is equals to
You said?
385.
What's the units? You're just telling me answers without units. Idani, are you done? Hello?
CM3.
You said?
M3.
Hello? Sorry, what did you say?
V2 is equals to 385 CM3.
cm cube, centimeter cube. Okay. Oh. Continue, don't worry. Continue to number two. Okay, Idan, are you done with number 1? Hey, Danny,
Come.
oh, seriously, till now? You're coming.
Number one.
Number 1 is
Fine.
what?
Number one. I kept the answers. 1,540.
1,005.
40.
Seriously? I think we should even work on this first before I give you the other part. Before you do number 2, please let's do number 1.
Number two is easier than
Number 2 is what?
number one. We're almost done with it.
No, I'm surprised that you're telling me this. Okay, let's see number 1 then. Let's do number 1.
So the answer for number 2
Is what?
between equal to 20
20 what?
cm cube.
20 cm cube.